Good afternoon to everybody. I hope you are doing well. From the last class we discussed regarding to the introduction to the introduction to the benzene nucleus we had discussed. In the introduction benzene nucleus, what are its characteristics, nature? What is the speciality of this unsaturated compound when you compare with the basic unsaturated compounds like alkenes and alkynes we had discussed, and its structure, structural representation, structural properties we have seen that. And coming to today's class, how benzene structure is going to be elucidated. What are the proofs, what are the evidences we have to conclude this is a benzene structure? Let me start to the discussion. Right. Evidences for structural elucidation of benzene in this. First one. Total entire evidences, entire proofs for the structural elucidation of benzene was categorized into three types: analytical evidences, synthetic evidences, and stability evidences. We will see one by one in an order. First one, analytical evidences. Everybody know that from the introduction part only we had discussed that benzene is a colorless liquid form which was isolated by the Michael Faraday in 1825. Michael Faraday in 1825 from the oily residue that collected in the illuminating gas lines of London. At that time, whenever in the production of illuminating gas, this is also benzene is isolated from that oily residues. In the process of illuminating gas production, from that oil residue only benzene was isolated by the Michael Faraday, and Michael Faraday determined that empirical formula. What is the meaning of empirical formula? Is nothing but ratio of the groups present in the structure. For example, if you take carbon, ethylene, C2H4, if you take C2H4, what is the ratio of the individual groups? What are the groups present in that? In this ethylene molecule, C2H4 is the general formula for the ethylene. If you observe this ethylene molecular formula, what are the general composition it has? One is carbon it has, another group is hydrogen. I will write like this: the carbon is to hydrogen, that equal to, I am going to mention as a 1:2 ratio. What it indicates that it's a ratio of the two groups, existence of the two groups in this molecular formula. 2:4. 2 carbons are there, 4 hydrogens are there. 2:4. I am going to further rationalized by the 1:2. I am going to divide by every integer value by the 2. So final the least ratio it exists is 1:2 ratio. How did we observe this empirical formula for this ethylene? Same way for empirical formula for benzene, that it has carbon and hydrogen of benzene as 1:1 ratio. We will see is it correct or not in the following process. And by the combustion analysis, how this empirical formula is going to be find out by the Michael Faraday is nothing but the process called as combustion analysis. One thing we need to recollect the basic concept from the first year level, 1-2 semester. In that we have seen the cracking process of alkanes, and combustion process of the alkanes, where what happened at that particular point of time regarding to the alkanes. We will see that. One is the combustion process, and the second process is nothing but a cracking process. What is the difference between these two processes? We are going to observe that. One thing you need to observe that both processes are the decomposition phenomena only. Decomposition phenomena only at the higher temperatures. The only difference is that in the presence of oxygen in the absence of oxygen. Which process we can call it as a combustion? See, combustion is a heating process, heating of a compound, organic compound, in the presence of oxygen. Whereas cracking is a process where we are going to heating the sample, in the absence of oxygen. Cracking is only we are going to use a heating process only at the higher temperatures. The temperature average, the range is 500 degrees centigrade to 600 degrees centigrade we are going to use. These are the two processes we have the knowledge regarding the alkanes. In the case of alkanes we learn. In these two processes, combustion analysis, by using the combustion process we are going to, that Michael Faraday determined the empirical formula as a 1:1 ratio, that those carbon and hydrogen are existing as 1:1 ratio, and finally followed by the molecular formula as C6H6. Simply I will give one example how combustion analysis procedure is going to be happen. What are the products are formed, based on that how benzene molecular formula going to be identified. We will discuss that process. Right, if you observe here, if suppose I had taken a benzene sample in a watch glass, sorry, I'm going to conduct in a vessel. I had taken the sample of benzene. I had taken as a benzene sample. I am going to heating this sample. I am going to heat this sample by using a Bunsen burner in the presence of oxygen. I am going to expose this RBF or conical flax. I am going to expose to the atmosphere itself. What happened itself? These things are going to be decomposed into the carbon dioxide and water. These are the final products under the combustion analysis. Any type of organic compound, if you are going to conduct the combustion process in the presence of oxygen at the higher temperature, what is going to happen, that it results in the formation of carbon dioxide and water molecule based on the composition of the sample itself. By using these products, how much ratios are going to be formed, based on these ratios the molecular formula of the benzene is going to be confirmed as a C6H6, and the empirical formula was identified as 1:1 ratio. Yes, 6:1, total 6 carbons are there, total 6 hydrogens are there, and both are cancelled by the 6. 1:1 ratio. Right. That is the analytical evidences. Analytical evidences give a evident proof, the formula to give the proof for the molecular formula of the benzene. Now coming to the next one is synthetic evidences. Yeah, okay, fine. We are ready with the empirical formula as a 1:1 ratio and molecular formula as a C6H6. Okay, fine. If you know the molecular formula, is it okay? Completed? You know the structure? No, we didn't know the structure itself. Still we didn't have any structural representation, any Lewis structure for the benzene nucleus. We only have the molecular form. Everybody scientists raise a question that what is the structure of benzene nucleus? That is that thought give the provision for still continuing the providing the still evidences and still continuing the study of the benzene nucleus. Right, synthetic evidences, the next category. After getting elemental composition of benzene, a question was raised, that is how these atoms are arranged. Okay, fine sir, molecular formula is C6H6. Total 6 carbon atoms are there, total 6 hydrogen atoms are there. How these are arranged? The question was raised, and that question only leads to the development of synthetic evidences. Let me see those synthetic evidences one by one. Right. Based on the elemental composition, different scientists come forward with a different structural composition. Different scientists come forward with a different structural composition. If you observe all the four structures I mentioned there, these all four structures having the common formula as C6H6. Let me check it out once. You should also count along with me. Now see here in this 1, carbon number 1, 2, 3, 4, 5, 6. Hydrogens, here 3, here 3, 6. The formula is C6H6. Now coming to this structure, if you observe here, total how many carbons are there? This is 1, this is 2, this is 3, this is 4 and 5 and 6. Total 6 carbons are there regarding this structure also, C6. Now how many hydrogens are there? Now if you check it out, the carbon valence in this structure, still one valence is remaining with the hydrogen. For here also one structure with the hydrogen. Here also still valence is remaining with the one hydrogen. Here also same. But if you observe here this carbon, total valence is satisfied 1, 2, 3, 4. Carbon valence was fulfilled. There is no hydrogen there. Now still how many hydrogens here for the methylene group? 2 hydrogens are there. Total it's 6. Now let me go to the remaining 2 structures. If you observe the benzene, this structure, this is one of the assumption structure. What is going to be observed there? 1 carbon, 2, 3, 4, 5, 6. Every corner indicates 1 carbon, and if you compare with the carbon valency, every carbon must and should has 1 hydrogen along with it. Every carbon contains 1 hydrogen itself in a covalent relationship. Then this molecular formula is also C6H6. Coming to this structure, if you observe this one, here also we need to identify the how many number of carbons are there. See if you consider this is a 1 carbon, there the 2 relationships are there. One is sigma bond relationship, another pi bond relationship. Still how many valency is remaining for the carbon? 2. The 2 carbon valency is remaining, is fulfilled by the hydrogens, CH2. Here also same, CH2. Now let me count the number of carbon atoms, number of hydrogen atoms in this structure. 1, here 2, 3, 4, 5, 6. For this also total number of carbon atoms are 6. Now let me count the hydrogen atoms. Terminal endings having the 2 hydrogens, total 4 hydrogens. Okay, fine. Now coming to here, if you observe here this carbon valence is satisfied. This is 1, 2, 3. Still valency is remaining 1. That valency was satisfied by the hydrogen itself. Here also same, 2 hydrogens. Here if you observe there, each 2 carbons are having the valency like this. See, this is 1 covalent bond, this is 1 covalent bond, and 3 covalent bond existing in the triple bonded system. So there is no hydrogen regarding these 2 carbons. Now total number of hydrogens itself C6H6. If you observe all these assumed structures, all are having the general molecular formula, common molecular formula, that is C6H6, what we can expect for the benzene nucleus. Okay, fine. In these different types of structures, which one is correct? And one thing we observe that we can also observe that if you observe all these structures, once I will show all the structures again. if you observe all the four structures itself, what is the common point, common characteristic of all these four structures? Unsaturation. See here, triple bonded system is there. Triple bonded system is there. Here, double bond character. Here if you observe that two double bonds are there, and here it is a one double bond. In this structure, if you observe that three double bond systems are there. And all the four structures we can observe that unsaturation character. What we know the basic example for unsaturated compounds in our earlier semester, we know that best examples are alkenes. The basic example for alkene is ethylene, CH2 double bond CH2. The basic example for triple bonded system is acetylene, CH triple bond CH. Now if you observe that, okay, one conclusion came to here now, the scientist. What is that? Okay, benzene, for benzene molecular formula also, the common point we observe that unsaturation behavior. Okay, maybe the benzene nucleus also behave like a basic unsaturated compounds like alkene and alkyne. They came into in that conclusion. Now what is going to be happen? What is going to be developed from that thought? It seemed clear that the molecule must be highly unsaturated. Yes, we are observing that unsaturation in all the four structures. This assumption leads to conduct and addition reactions which are characteristic reactions of alkenes and alkenes. Yes, in the first year we had learned regarding the alkenes and alkynes. Markovnikov's addition reaction, Markovnikov's electrophilic addition reactions. We have seen that. Once you recollect that concept also, right? Coming to that, the same addition reactions we can expect. The scientist come into one assumption that okay, these also having the unsaturation. Benzene also having the benzene assumption structures also having the unsaturation. Maybe benzene behave like these basic compounds. Let me check it out. For that, they conduct the reaction, addition reactions. They start to conduct the addition reactions. What is that addition reaction they conducted? Simply reduction. Benzene sample they had taken. See, I had taken, this is a original structure, but it is you should consider as a sample itself. Benzene sample upon reduction, I am going to do the hydrogenation. I am using the hydrogen, I am going to pass the hydrogen gas, gaseous form, hydrogen gaseous form into the sample at the finely divided nickel catalyst. I am using the metal as a catalyst, and here 300 degrees centigrade at the 30 atmospheric pressure. And what is going to happen there? It results in the formation of saturated compound, right? So until now we observe that for a benzene nucleus, see, the hydrogenation results in the formation of a saturated compound. All the unsaturation behavior converted to the saturation behavior, and how it is going to be further leads to the further studies we will discuss in the next class. Thank you.